Hey, top Airlines Math Industry, and we are going to take a look at add and subtract fraction rationals, part 1. So, we've learned about long division, we've learned about all the different rationals and how to graph them. But what we're going to do is try to add and subtract the fraction rationals. So, going back to your middle school years, you probably learned about adding and subtracting fractions. So what we're going to do is solve these two problems, so it will help us continue. When you add or subtract fractions, it's a good idea to make it as simple as possible. Try to keep all of the denominators the same. For example, if we have 3 over 7 and we have 10 over 6, we need to find some kind of common denominator that will help us out, because you can't mentally do this and that, which is very, very hard to do. So we have a 7 and a 6. What can we use, or what number can be used to get to a common denominator? Yeah, we have to multiply this by 6 and multiply this by 7 to get 42 and 42. But we have to multiply this by 6 and multiply this by 7 to get 70, and 3 times 6 is 18. So 70 plus 18 is going to be 88 over 42. I'm not going to simplify because I want to make it easy for everyone to see the math and see what happens. So it's a good idea to put everything to a common denominator, because that will eventually reach to this. What about the one over here? We have 18 over 8 and 2 over 4, but we're minusing it. 4 and 8 are going to stay as 8. So this is 8, and this is 8. Multiply by 2, multiply by 2, multiply by 1, multiply by 1. So 18 over 8, subtract that by 2 times 2 is 4 over 8. And 18 minus 4 is 14 over 8. Again, I'm not going to simplify because I want to make the math as easy as possible to understand. And the reason why we did this is because we can actually apply the same kind of strategy to solving these kind of problems in the high school level, a high school algebra class. So right over here, we have a minus 1 divided by a and 2a plus 3 divided by a. This should be very easy because these two things are the same denominator. Therefore, it will allow us to actually have the a minus 1 and the 2a plus 3 as added together because they're the same denominator. So we have 3a plus 2. That is our final answer, which is very easy to recognize. Let's try another problem. With this problem, see how they have the same denominator? We have this and that. But what are we going to do with this? There's a subtraction sign. So we're going to multiply it by this, multiply it by that too. So we are going to have on the bottom m minus 3m for this one, but also this becomes a negative m, and this becomes a negative 3m. So when we combine the like terms, we get m and m is 0, so nothing appears with the letter m, and we are going to have negative 6m. But we're not done yet. We still have to do this and the that. So we have to add that by the divisor of 1 because it's trying to explain what the final answer is. But hey, we forgot something. If we have to explain the divided, or what we're trying to divide, this is not the right answer. We still have to divide by a. Now that's the right answer. So when the problems are like this and that, where the denominators are similar or the same to each other, it makes a lot of sense that the problem's going to fly by and you could just easily add and subtract. But sometimes we might have to do a little bit more steps. sometimes it can be a little bit more complicated. So for this kind of problem, we will require more steps to solve it out. And we're going to solve it slowly. So you see how the 5x plus 4 and the 2x plus 3 are different denominators? That is something we don't like to have. So we have to use the same method we learned in middle school, where we put both denominators the same in order to give us a fast pass to our answer. What can we do? Well, what we can do is if we multiply this blue on the side, 5x plus 4, and if we multiply the red right over here, we get 2x plus 3. The 2x plus 3 is going to go with the 2x, and the 5x plus 4 is going to go with the 6x. Now we have to make some kind of equation, because what will happen is these two will cross out, and these two will cross out. There is going to be a new equation. The new equation is going to appear like 2x plus 3, but then we multiply it by 2x. That's because this and that, and we cancel that. If we take a look at the blue equation, then we are going to have on the other side 5x plus 4 in parentheses. Then we have to multiply by the 6x. So now we have to add the two. So now we know that this and this is going to cancel, but this is going to multiply with that. Here is going to be our new numbers. So for the red equation, we get 4x squared plus 6x when we multiply this and that. For the blue equation, we are going to get 30x squared plus 24x. Now we have to add them. We now have to combine like terms so it will help us get to our final answer. So when we have this and this, 4 and 30 is going to go into 34x squared. And we have a 6 and a 24. So it's going to add to 30x. So we have that as the numerator, but now we have to divide that by something. It's not like we're trying to get to some kind of answer where there's an equal sign. There doesn't appear to be an equal sign here because we have no clue what x represents. And number 2, we're not trying to find what x is. So we have the 5x plus 4, and we're going to put that on the bottom. And we have the 2x plus 3, and we're also going to put that on the bottom. I'm just going to color this blue, and I'm going to color this red. And this is going to be our final answer. This is what you will receive when you try to add or subtract fractional rationals. Sometimes your math test or your math assignment is going to have the word reduce, because you're not actually solving for the problem. You're just trying to find out, if I were to add these two, how would you reduce it into something that makes a lot more sense, or something that's more simple. Let's take a look at another problem. So, this problem has us subtract the numbers. So what are we going to do? Yeah, I'm going to color code. So this is blue, and this is red. So here's what happens. The x plus 2 is going to go right to the opposite of where I highlighted. For the blue equation, it's x minus 3. The x plus 2 is going to be multiplied to the number 2. And the x plus 3 is going to be multiplied to the number 1. So here is what's going to happen. 1, parentheses, x minus 3 is our blue equation. And now we have to subtract that by 2, parentheses, x plus 2 as our second equation. So let's try to see what happens. We have a negative 2 because the negative 2 is going to tag along with the 2. The negative is also going to be distributed. So in reality, the equation for the red one is going to be negative 2x minus that by 4, because that subtraction symbol is going to also put itself into the distributive property. And the 1 and the x minus 3 is going to be this times that, and that times that, just x minus 3. When you add the two using simple math, you're going to get an answer of negative x minus 7, because you're creating elements from these two, and you're creating the x from these two. So negative x minus 7 divided by, we have x plus 2 and x minus 3. And that is going to be for red and blue. That's going to be what we're trying to divide with, but we're going to have them separate. We're going to have them separate because we don't want to try and FOIL them together or multiply them together. The x plus 2 is going to be in red, and the x minus 3 is going to be in blue. So that is how we add and subtract using the middle school stuff we learned, and that's how we also add and subtract fraction rationals. I hope this video has helped you understand adding and subtracting fraction rationals. Thank you for watching Top Analyze the Math Industry. Like and subscribe.